The New Horizons mission, launched on January 19, 2006, marked a pivotal moment in our exploration of the outer solar system. After nearly a decade of travel, the spacecraft made its historic flyby of Pluto on July 14, 2015. This event not only excited scientists and space enthusiasts around the world but also fundamentally changed our understanding of Pluto and its moons. Background of the mission: the journey to Pluto began with a push from the scientific community, which argued for the importance of studying this distant celestial body. Pluto, once classified as the ninth planet, had been redefined as a dwarf planet by the International Astronomical Union in 2006. This reclassification sparked debate and led many to consider Pluto less interesting compared to its larger planetary counterparts. However, the New Horizons team recognized the significance of studying Pluto, given its unique characteristics and the mysteries it held. The New Horizons spacecraft was designed to be efficient and swift. With a primary mission to reach Pluto as quickly as possible, it was equipped with a suite of scientific instruments tailored for remote sensing. These instruments were intended to capture high-resolution images, analyze surface compositions, and study the atmosphere of Pluto and its moons. The mission's scientific goals included understanding Pluto's geology, composition, atmosphere, and the relationship between Pluto and its moons, especially Charon. Launch and Journey: New Horizons was launched aboard an Atlas V rocket, which was one of the most powerful rockets available at the time. The launch itself was notable for its speed, enabling the spacecraft to pass the Moon in just 9 hours, an impressive feat compared to the Apollo missions, which took much longer. This rapid transit was made possible by the spacecraft's lightweight design and powerful propulsion system. After its launch, New Horizons embarked on a long journey that included a gravity assist from Jupiter. This maneuver not only accelerated the spacecraft but also provided a unique opportunity to test its scientific instruments. As New Horizons flew by Jupiter in February 2007, it captured stunning images of the gas giant and its moons, demonstrating the spacecraft's capabilities and giving scientists a preview of what was to come during the Pluto flyby. After the successful Jupiter flyby, New Horizons entered hibernation mode to conserve energy and protect its instruments from wear and tear during the long journey to Pluto. During this hibernation, the spacecraft would periodically wake up to send status reports back to Earth, ensuring that all systems were functioning properly. Approaching Pluto: as New Horizons approached Pluto in 2015, anticipation grew within the scientific community and the public. The team began to reactivate the spacecraft's systems and prepare for the closest approach. In the weeks leading up to the flyby, New Horizons started sending back images of Pluto, gradually increasing in resolution and providing tantalizing hints of what was to come. The heart-shaped feature, later named Sputnik Planitia, captured the attention of astronomers and the general public alike. On July 14, 2015, New Horizons reached its closest approach, flying within 12,500 kilometers of Pluto's surface. During this flyby, the spacecraft was programmed to collect a vast amount of data, taking high-resolution images and measurements of Pluto's atmosphere, surface, and geological features. Although the spacecraft transmitted data back to Earth, the slow communication speed, just 1 kilobit per second, meant that it would take months for all the data to be fully received and analyzed. Scientific discoveries: the findings from the New Horizons mission were groundbreaking. Among the most striking observations was the complex geology of Pluto. The heart-shaped Sputnik Planitia, a large ice plain primarily composed of nitrogen ice, showcased features that suggested ongoing geological processes. The lack of craters indicated that the surface was relatively young, possibly only 10 million years old, suggesting that Pluto is still geologically active. Scientists noted that nitrogen ice at the temperatures present on Pluto can flow like water ice on Earth, allowing for the formation of glaciers. The images revealed striking polygonal shapes across the ice plains, likely created by sublimation, where ice transitions directly into gas. These features highlighted a dynamic environment where changes are occurring, making Pluto far more interesting than previously thought. Pluto's atmosphere was another area of significant discovery. New Horizons provided evidence of a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. The spacecraft also measured atmospheric pressure and temperature, revealing how Pluto's atmosphere behaves and changes with its orbit around the Sun. The observations showed that Pluto's atmosphere expands as it approaches the Sun and contracts when it moves further away, suggesting complex seasonal cycles. Pluto and Charon. A unique relationship. One of the most fascinating aspects of the New Horizons mission was the relationship between Pluto and its largest moon, Charon. Unlike most planetary systems, Pluto and Charon are tidally locked to each other, meaning that they always show the same face to one another. This unique relationship results in a barycenter, an imaginary point in space around which both bodies orbit, that is located outside of Pluto. This phenomenon is rare in the solar system, where typically a planet is much larger than its moon, making Charon a significant player in the Pluto system. Charon itself is visually distinct from Pluto, with a darker surface that suggests a different origin. New Horizons provided detailed images of Charon, revealing its own geological features, including canyons, mountains, and possibly even signs of past cryovolcanism. The spacecraft's data suggested that Charon might have undergone a history of geological activity, adding another layer of complexity to the Pluto-Charon system. Exploration beyond Pluto. While the primary focus of the New Horizons mission was Pluto, the spacecraft was designed to continue its journey beyond this dwarf planet. After the successful flyby, the mission team identified a potential target for a second flyby, a small Kuiper belt object named 2014 MU69, later renamed Arrokoth. This object is believed to be a primitive building block of the solar system, providing an opportunity to study the early materials that formed the planets. In January 2019, New Horizons made its closest approach to Arrokoth, capturing detailed images and data that further expanded our understanding of the Kuiper belt and the formation of the solar system. The information gathered from both the Pluto and Arrokoth flybys has provided insights into the composition and behavior of distant celestial bodies. Impact on planetary science. The New Horizons mission has had a profound impact on planetary science, changing how scientists view dwarf planets and the outer solar system. The data collected from the mission has led to numerous scientific publications and discussions about the nature of icy bodies in the Kuiper belt and beyond. It has spurred interest in further exploration of these distant regions, as scientists continue to uncover the complexities of our solar system. Moreover, the mission challenged long-held assumptions about Pluto. The data suggested that Pluto is a dynamic world with geological features similar to those found on larger planets. This realization has prompted scientists to reevaluate other dwarf planets and small bodies in the solar system, encouraging a broader understanding of their potential for geological activity and atmospheric processes. Public engagement and legacy. The New Horizons mission also engaged the public in unprecedented ways. As images and data were released, people around the world followed the mission closely, sharing in the excitement of discovery. The iconic images of Pluto, especially the heart-shaped Sputnik Planitia, captured the imagination of millions, leading to an increased interest in planetary science and space exploration. The mission's success has inspired future generations of scientists, engineers, and explorers. It has underscored the importance of exploration and curiosity, reminding us of the value of understanding our place in the universe. New Horizons has set a benchmark for future missions to the outer solar system, demonstrating what can be achieved with careful planning, innovative technology, and international collaboration. Conclusion. In summary, the New Horizons mission transformed our understanding of Pluto and its moons, revealing a complex and dynamic system that challenges our previous notions of what dwarf planets can be. Through its detailed observations of Pluto's geology, atmosphere, and relationship with Charon, the mission